All right. Good afternoon, everyone. Welcome to Accelerate DFX Session 2, designed for manufacturing assembly and cost. First, just a couple of housekeeping items out of the way. One, bathrooms are out the far door over there and then to the right. Second of all, if there's, for whatever reason, a fire or an emergency, our exit is towards Duke Street, so also towards that exit, and you'll be notified of instructions if there's anything. Now to sort of just give a quick intro, so the man behind me, Kurtis, was a big pusher for something like this because the way he described it to me, he's like, I made so many mistakes early on that I don't want to continue to see when starting a hardware company. So we decided to put this event together to give as much information as we possibly could about what it takes to take an idea for a physical product and actually get it to market. Yeah, so the AC is really happy to support those sort of endeavors, and we're really glad you were able to make it out today. So without further ado, I'm going to hand the floor over to Kurtis McBride from Miovision. Also, just a quick shout out, the City of Kitchener was really great enough to give us this room for this event, so we would also just like to thank them because they've been really awesome for this. All right. Thanks. Go ahead.
And for the record, I didn't say I made so many mistakes early on. I just said I make so many mistakes. Yeah, I feel like as much as you learn about making hardware work, there's always more to learn. And whenever I give tours of our manufacturing space, I always say they don't call it hardware for nothing. It's not easyware. Anyways, just maybe show of hands. I've done this talk once before, but show of hands, how many people know what DFX is? You're here, so hopefully, okay, so that's more than the last time I gave this talk, so that's good. I feel like Tony Robbins with the cameras and the wireless mic and everything. So yeah, I guess super quick overview. For those of you who don't know Miovision, we started the Accelerator Center we moved in there in 2006. Started the company just before that, 2005. We actually just moved for the 5th time about 3 weeks ago into a project on Glasgow called Catalyst 137, and it's a project that's specifically designed for the needs of hardware companies. So a lot of what I'm going to talk about through this talk, we've tried to make a physical place that compiles expertise that would help you to address some of the stuff as you go along. We got our start doing, if you've ever seen like college students counting cars with clipboards and lawn chairs at the side of the road, we got our start building technology that sort of automates that process. So cities want to understand, how many cars are going through an intersection, going, north, south, east, west. They go out and they traditionally have done manual counts, and we have incrementally added technology into that world. But I want to go through and talk about 5 things that we've learned over the years that I wish I had known early on as a startup, because it would have changed my approach to engineering. It would have changed my approach to how I raised capital and things like that. So if you haven't figured out, I'm a fairly informal guy. So we'll go through these, but I'd love to take questions at the end about any of this. And for anyone who's at the Gawkel session and has seen some of these slides before, I will apologize in advance. I'll try to tell different jokes this time. So the first one, plan for working capital. So one of the things that we did and a lot of the early stage hardware companies that I meet do is you build this model that takes into consideration your biggest expense, which is your salary expense, right? So you have your salaries, you're building your products for a while, eventually you have revenue flowing in there, you're making a margin on it, all things are great. You go out and you raise money to bridge through that period where you're building your product, and then something happens which is great. You get your first big order, right? So you've been selling like 1s and 2s of things, all of a sudden you're selling 100 of something. And what you didn't think about was that you have to go out and buy a whole bunch of raw material to build all your hardware, and then you have to build it, and then you have to ship it to your customer, and it's your first big order, so you were super nervous when you negotiated the terms and you agreed to they don't have to pay you for 60 days, right? So you bought your inventory, you're a new company, the supplier networks are like, I want money up front because I don't trust that you're going to be around long enough to pay me. So you pay them, they ship it, maybe it takes you 60 or 90 days to ultimately turn all that stuff into products that you ship out the door, and then it takes another 60 days that your customer said they would pay you, and they're stretching you, so it takes 90 days, right? So now you just had a 6-month gap where you had to spend a whole bunch of money and you still haven't gotten paid. And that's different than a SaaS startup, right? SaaS startups, they have a little bit of maybe AR, like accounts receivable, where their customers haven't paid them yet. But a lot of times they're taking credit cards, they're getting paid up front for services. That's not usually the case with hardware. So I generally would recommend that you guys, before you go out and do your first big raise to go and sort of build your businesses, spend a little bit of time. And I know as engineers, like we don't think this stuff matters, but spend a little bit of time understanding balance sheet mechanics and specifically how your inventory and your accounts receivable will impact you, because that will often cost you more money than actually building your product. And if you're not careful, you get in a pinch where you have to go raise more money just to ship your first big order, which kind of sucks. Been there. Number 2. So you go out, you do your first raise, you make a whole bunch of promises that you probably can't keep, and but you want to get to market, right? You got to show proof point, you got to show market validation. Our rule of thumb now is when we would have said a product is done when we first started the company, that's usually about the halfway point for a project, for new hardware project. Really spend the time. I remember our first project that we built, hot glue was one of the bill of material items. We took that to a contract manufacturer, said we want you to go build 100 of these, and they looked at us like, are you kidding me? Like, this is never gonna fly. Things like our first big customer was in Texas, and we shipped them 10 of our systems, which at the time for us was a big order, and every single one of them arrived at the customer site DOA, like not working, right? So I go down to the manufacturing floor and use some choice words about the importance of quality and the importance of this big customer, and decide that I'm going to personally inspect every single unit that comes off the line to make sure that it passes our quality check, right? So we spend the day, we rebuild these 10 units. I personally go through and check every single one of them. We put them on the truck, call the customer and assure them, this time is different. I've personally inspected every single one of them, and we ship them to the customer, and they arrive, and every single one of them is DOA. And so at this point, we got to know a guy who came in and convinced us to buy a vibration table. It's like the best $2,000 we ever spent, because what was happening was, as we put these things on a truck and drive them across North America, they're shaking as they go down the highway, and by the time they got to Texas, all the cables had sheared because there was lots of places where they could be cut, right? So I would say, you will test invariably the things that you can think about. I promise you there are 100 times more things that go wrong with hardware that you don't think about. Spend the time up front to understand how to test and to actually test, because the downstream cost of shipping a bunch of units to Alaska and having them fail because it's cold, or Dubai and they fail because it's hot, the cost of that is 100 times more than the cost of just fixing it before you ship it, even though it's going to feel like you're spending money that you don't need to and you're spending time that you don't need to. You won't listen to me. You'll learn this yourself, but trust me, you should spend the time. So the next one, I see this a lot. We did it. I see this a lot with early stage companies. You go through and you build one of something, and in general, as a startup, we love iteration, right? Like the market's teaching us stuff. We're iterating all the time. And we do that with our hardware designs, right? We design it, and we'll deal with the quality as they come up, and we'll iterate. Contract manufacturers, their entire business model is set up around stability, right? So you give me a very stable design with a very stable set of build instructions and a very stable set of test instructions, and I can build 100 of those, super fast and really cost effectively, and deliver you, 99 that work out of the 100 that you want me to build. If you go to a contract manufacturer too early, when you're in that iterative mode, they they hate working with you because you're super iterative on their line, and you're not only disrupting your own product flow, but you're disrupting all of the other products that they're trying to stick down the same line. So while I would say talk to contract manufacturers, there's a great one that's actually moving into town shortly called Sigma Point that has DFX as a service. The way they look at it is, before you get onto the line, we want to go through and sort of work with you to audit your design as early as possible, right? So don't wait till you finish the thing. Go to a CM up front and get them to audit your even your conceptual designs, so that they can get you thinking about designing for manufacturability, designing for cost, designing for quality, designing for production velocity, whatever it is that matters to you. And so don't think you can put your product on their line early, but don't be afraid to talk to them early. But really, my advice would be prepare to build your own units, for the first 100, 1,000 until your design is stabilized. And this probably, if there's any CMs in the room, I apologize, I don't mean this how it'll probably sound, but when you're working with CM, think of them as literally tactical work, right? Think of them like pretend that they need you to explain every little detail of every step of your process. Most of the good ones you don't need to go that far, but if you come at the problem that way, then there'll be no room for any misinterpretation or any missed steps that will result in quality. This is another one that I don't know if it's as relevant to DFX, but is also important as you guys think about how you're going to grow your businesses, and assuming you may have to raise capital multiple times. The way the market generally looks at hardware versus recurring revenue, hardware you're going to get somewhere between a 1 and 3 times revenue multiple, even if it's sort of theoretical revenue in the future. Whereas like software as a service, recurring revenue, you're going to get a 5 to 12 times multiple. Right? So what will often happen is if you are an IoT company, you sell both hardware and software, they'll look at sort of a sum of the parts, right? So they'll look at how much hardware you're selling, how much software you're selling. So to the degree that when you're building your business models and ultimately you're coming up with your pricing models, as much as you can trap the value of what you do in the recurring revenue model as opposed to the upfront hardware sale, like it's great. You get the cash up front from the upfront hardware, so you're inclined, as a startup, you're inclined to do that. But if you think sort of a few steps ahead of yourself, as much as you can move that value that you're providing into the recurring piece, it'll drive your value up, which will allow you to raise more money, which will allow you to de-risk your business, grow faster, all that good stuff. So you're sort of trading, future you will thank you, even if you today struggles a bit more. But even when you're going out and showing investors the models you're building, building that recurring base will do wonders for you. This is another one that I talked about in the beginning, kind of joke about, not just having problems that we learned a long time ago, but still having problems. How many people in the room have both hardware and software in their businesses? Okay, so in software, it's quite typical to use what's called Agile methodology, right? So you basically like iteratively develop your product. You learn from the market as you go, you deploy every week, every month, every quarter. In hardware, it's much harder to do that because you kind of want to get your design done, do it, stabilize it, ship it. So what will happen is you'll tend toward a waterfall process in your hardware team and an agile process in your software team. So on the surface, that doesn't seem like a problem. But what will happen is those are fundamentally different cultures, right? The types of people who want to work in one or the other environment, the type of systems they use, the types of tools they use, even the types of language they use to describe process, they're different. So you will often find yourself in your engineering team, having to rationalize those two different delivery methods. And then as your business grows and you add sales and marketing and shared services like finance and HR, how you think about delivering programs, like delivering new products into your business or delivering change into your business, that conflict between sort of the agile thinking and the waterfall thinking will scale with your business. And if you're not careful, you end up with essentially two planning cultures, right? So you have a common corporate culture, but you have two planning cultures, one that wants to think very sequentially and one that wants to think very iteratively. And if you're not careful, that can create tension and inefficiency in your business. So this is one where like you probably don't run into this at the scale that a lot of you guys would be at. But when you find yourself making decisions about what kinds of planning and development processes to put in place, be conscious of the fact that one day these two animals will fight each other, and you'll have to deal with it by putting one of them down. So yeah, that's those are the sort of the lessons that I want to share. You know, I think the fact that the fact that we're all here talking about DFX, I think is super important. When we were getting started, 10 years ago, there was some of the guys from Pickstream that had just started Sandvine, who were kind of like the go-to guys in the community for DFX. But you didn't even generally know that was something you had to think about or ask about. So the fact that there's a conversation happening in the community, I think, is going to be great to shorten time to market for hardware companies. So great to see it, and happy to take any questions you guys might have, or not. I feel like I should pick on somebody because then the questions will start flowing.
So when you just talked about the two Agile Waterfall, did you find was one that
So I'm in the process of putting one of them down right now. So in our, every business is going to be different, but for us, Agile is the one we've picked as the common planning process. The world's changing like ever faster. So while you still have to design hardware using waterfall methodology, we've decided to standardize the broader business planning culture around Agile. It's not. It sounds easier to do than it is. Like there's a lot of well-established. You hire in. Even things like you have a board and they want an annual budget. Well, that's very waterfall, right? You set goals annually, you budget annually. That's a very waterfall approach. So in the philosophical sense, moving to Agile where you can respond quickly to market changes and to as you learn stuff, and it makes a lot of sense. But the actual act of doing that at scale, it has proven to be an interesting challenge. Even just teaching, we find internally we've actually taken a lot of our software like project managers, like Scrum Masters, we've actually taken them, and as sort of a extracurricular activity, we've sent them out into the business as ambassadors to teach Agile, because even just the general principles of Agile, which are probably quite well understood in this room, if you want to apply that to sales, right? It's not a thing that they have any sort of basis for comparison. So but Agile is where we've landed, and I figure probably by the end of this year, Waterfall will be maybe not dead, but at least like squirming on the ground, incapacitated. Any? Yeah, go ahead.
You also mentioned the impact of hardware and software on valuation multipliers and how to split the business. How have you thought about Miovision in terms of hardware and software, and where you're investing, which things lie on what side of the problem to solve?
Yeah. So I mean, none of this is like an exact science, but our general approach has been for hardware to target a 50% gross margin. So if it costs us $100 to build something, we just sell it for $200. And the idea there is that, at least in our business, that's generally enough room to cover you have an R&D team that has to build the next version, you have some, overheads of, your shared services group, you have some sales commissions, whatever. So generally we can run our hardware as like a break-even business unit if we were to look at it as a standalone thing. And the only reason we do that is that when we go raise money, and someone ever wanted to slice our business and just look at how the hardware was performing, they would see a stable standalone hardware business. And then we basically price the software where we take the overall value we think we're delivering to the customer, right? So we're not as sort of multiple of cost approach there. It's more of like, what's the value of the proposition and how are we changing the business of the customer? And then we sort of notionally subtract out, we typically use like a 5-year lifespan of hardware. So we notionally would subtract out of that value proposition, to get to an annual software value, we would subtract out 1/5 of the value of the hardware sort of notionally. And that's kind of how we do it. I mean, it's not an exact science, but that allows us to sort of, pass the sniff test of a stable hardware business while trapping as much of the remaining value in the software. So we've debated sometimes even, moving more of it into the software and just living with the fact that we have a loss leader sort of hardware business. But yeah, that's kind of where we've landed.
Do you find the amount that you're making per hardware on the software side, is that kind of stable, or is that growing over time? Like as you get more mature in the business, are we able to make more money on the software side for every hardware? Or is that kind of through the life of it?
No. I mean, so because the software is linked to value proposition, I mean, as you're adding more modules, more capabilities, like, yeah, we're always seeing I should say always. We hope to always see an accretive ASP on the software side. On the hardware side, we actually see some, I mean, as you build more of something and as the chipsets you're using age and, all that kind of stuff, you generally see declines in your BOM cost. Our approach there, as a general rule, has been to reinvest so let's say it costs us $1,200 to build, widget X, and let's say, we go through an exercise of renegotiating with all our vendors and we get that down to $1,100 to build the same widget. Instead of pocketing that, we generally, it's notional, sort of philosophical, but generally would reinvest that $100 in quality. So we generally accept the 50% margin and try to drive up yields or try to drive up, longevity of device and like the meantime to failure, in terms of like the useful life of the hardware, or give offer longer warranty terms. So basically try to make the hardware a complete de-risked no-brainer for the customer, and fix that 50% margin. But I mean, there's been times where we've just pocketed the margin too. But yeah, as a general rule, I find as you scale the business, you need to operate. You can't be everywhere, so you need to put in place sort of like operating frameworks to help people understand how they need to make decisions. So rather than sort of fine tuning, this time we'll do it for margin, this time we'll do it for that. If you just leave behind 50% and focus on quality, that's a scalable process because you can sort of build up norms around it. But yep. Anyone have any questions just on things I didn't cover, like what's keeping you awake at night? Or you have all the problems solved?
I was wondering how dependent you are on CMs, like how much of the manufacturing process are you still able to do in-house or prototyping?
Yeah, it's a good question. So I'll actually take you through all the way from design. So our general philosophy is we know our customers best. So we do the sort of technical product management part of hardware development. So we go out and understand, what's the problem we're trying to solve and how does the hardware form part of that solution. And then we generally write what we would call like acceptance criteria, sort of like design validation criteria. So sort of say, we know this project's done when it's passed these 75 tests, right? Then we have a hardware team internally, but their job is mostly to spec the upfront design and spec the testing. And then we generally outsource the actual creation of the hardware to people who that's their specialization. And then so we keep that, when we get back the first articles, our team's like all over doing the testing, spend a lot of time there, often driving the other side, the people we've outsourced it to nuts because they're like, why are you so neurotic about all of this stuff? And then we would go to the CM and sort of hand it off to the CM. Our general philosophy is we would always do final assembly because then that's the thing that's closest to the customer. So we would use CMs for plastics and cables and circuit boards and metals and sometimes we aggregate, like sometimes we'll buy sub-assemblies from a CM. But that last sort of putting, it could be as simple as like take finished product, put in box, but there's lots of unit testing we do before we ship it. So sort of like defining the product, testing the design, and then testing every unit that goes out the door. We keep that, and we generally outsource everything else. That's the kind of balance. We've swung the pendulum back and forth, and that's kind of the balance we've found that works best for us. Yeah, I mean, CMs are, that's why I sort of said, like, think about it like that, but don't do it like that, right? So think about it as you need to define everything. A good CM will be a partner in there and will generally even teach you how to define it for them. But yeah, we would give the CM that leeway, but we would want the sort of ground truth set of documentation that describes the process to be updated. So that, if that CM's, they disappeared tomorrow, it'd be a big bust for them to get hit by a bus. But like, if they disappeared tomorrow, you could take that set of documentation and everything they've learned on their line applied to your product assembly, you could pick that up and move it to a different location and start in a week kind of thing, as opposed to having to relearn all that stuff. So yeah, we give them leeway, we give them the latitude, but we try to capture it all. Thank you.
So this is our second time doing this, and both times I've now forgotten to introduce myself when I say hi. So I'm David Hussey. I work with the Accelerator Center. I am the Client Experience Coordinator for 44 Gawkel. So at this point, we're going to introduce the panel. I'll start off by introducing Don Thompson, who most of you will know is the Accelerator Center's product development mentor. He only agreed to do this if he got to sit in the mayor's chair, so you'll notice that's exactly where he's been located. So at this point, I'll leave to him to introduce the panel and begin the moderating.
Thanks.
It was better than the last time I did the joke.
A little more respect in the mayor's chair.
Yeah.
So thank you all for coming out today. Another great turnout. What we're going to do is turn over the panel for the next 45 minutes and really just talk about a couple of key themes. What I've outlined in more questions, certainly. How does it start to develop with manufacturing, assembly, and cost in mind? What can I expect from the various partners I engage with in the early days of my product developments? The things like the CM, who do I trust, who do I not? What's involved in maintaining it long term? Because change is going to happen, and how do we manage that? When do I need an expert? And then hopefully horror stories. Fire, brimstone, hopefully not PCBs, you know what I mean? That can be painful, I think. But we want to talk about that, because the whole point of this is there's people here who have made a lot of good decisions, but also made a lot of bad decisions. And so how do we help you guys learn from our scars and use this as an opportunity to share any of the questions and concerns that you all have. Okay, so I'm Don Thompson, the product development mentor at the Accelerator Center. 20 years of doing product development, mechanical engineer, recovering, mainly focused on product management now and project management for the AC clients. Okay, so Kurtis, you've already introduced yourself, so Mr. Bob.
Hi, my name's Bob Rushby. I'm the technology mentor at the Accelerator Center. I'm retired. I was at Christie Digital for 12 years as their Chief Technology Officer. Before that, I worked for a company in Toronto called Delphax that at the time made the world's fastest electronic printers. Before that, I was Director of Engineering at NCR Corporation in Waterloo. So my background's electrical engineering, and I've designed and developed many products through really talented teams. I've also had the opportunity of twice in my career, once at Delphax and once at Christie, on an acting basis, be VP of Operations. So I've seen the manufacturing outcomes firsthand of what my own engineers developed. So I've seen design for manufacturing for both sides, and I really respect and think manufacturing is one of the most important things we can do. So.
My name is Raymond Auto. I'm president and owner of a company called Inertia Engineering. Also have about 20 years experience in product manufacturing, starting in the automotive industry, and also in design and development of in motorsports, so vehicle design, and did that for about 10 or 15 years before starting my company just a bit over 13 years ago. So Inertia helps I would say early stage startup and early stage companies, as well as high growth companies, design and manufacture their products. And it could be anything from sports wearables to medical devices to kitchen appliances. So we've been working with the Accelerator Center for the last year on various lunch and learns as a partner to help kind of spread the word about hardware design development and manufacturing. Thanks for having me here.
Cool. Okay, so themes. How does a startup develop with manufacturing, assembly, and cost in mind? So what I want to start off with is just, what are some of the tactics that should be considered as part of that process that we look at in the early stage of this? So why don't I turn that over to Ray to give it a go?
Sure. I think it starts right at the market requirements or customer requirements, defining what your product needs to do. So we're a service company, so we're working a lot with founders, startups, and they've got a very good vision, and people always want to cram the most into their product to start. So from the requirements comes the functionality of the product, and from functionality comes, the appearance of the form, and then it comes manufacturing process selection, and then out comes cost. And so a lot of that is, I think, a lot of we talk about design for manufacture, design for assembly, design for cost starts in the requirements phase. And I can share, I wouldn't say horror stories, but lessons learned about getting to a point in the process and having to back up because we're trying to cram too much into a product and blowing cost targets.
Well, it's interesting because one of the things I'm always harping on are actual requirements documents. It's something that very rarely do I actually see, and so I usually start with a bar napkin and start writing it out because it's not hard. Once you make that first step, then it kind of flows from there. So I don't know, Bob, what are some good requirements documents that you've seen just from even your background with engineering and manufacturing that kind of came from the product?
So, Don, I'm actually not in love with requirements documents. To me, the best...
I'm turning you off. Delegate off.
The best requirements document, I think, well, there has to be something written down as a starting point. But you're interacting with marketing, you're interacting with product management, you're interacting with target customers. To me, requirements can evolve, perhaps like in the Agile process you were discussing, Kurtis, through refining and iterating prototypes, proof of concept through prototypes, and then it converges into what you're actually going to design. So I think the requirements document is actually not at the beginning of the process like it was when I began my career. I think it's a third of the way into the process after you've iterated through a proof of concept and early prototypes and taken them to customers for review.
What do you think, Kurtis? I disagree with Bob. Kind of.
I'm sorry, I agree with Bob.
Damn you. I'm kidding.
Yeah, so our approach in the sort of agile sense, so we do what we call PRDs and TRDs. So in fairness, they're not documents, but we do have a spreadsheet that is product requirements. So the PRD would be basically a whole bunch of line items broken out into whatever categorization makes sense for your product. And those are sort of like user or buyer facing requirements. So as a user, I want to blah so that I can blah, right? As a buyer, I want to blah so that I can blah, right? Pretty standard Agile stuff. And then, so that's how we define the PRD. And then the TRD is the technical requirements document. So that's where we sort of take, okay, given all of these user and buyer requirements, then we define, all of the electrical and mechanical and, environmental and all of those kind of criteria. Where DFX comes in is that what I just described is how you would traditionally do it. What DFX would suggest is that user and buyer are not your only customer, like you're not your only user. So DFX is designed for manufacturability. So how is the CM going to respond, and what do they care about, right? Your finance department designed for cost, so you can't have the thing cost anything. So and so we apply the same PRD kind of idea to DFX, and then in the TRD sense, a lot of that stuff will then flow from your requirements into your TRD.
There is one document I've always insisted my teams do right from the beginning, and that's a bill of materials, which seems odd because you haven't got a design. How do you do a bill of materials? You can conceptualize your bill of materials, break down your product into conceptual modules, predict or anticipate what you think the cost goals are for those, and then you can refine that week by week as you iterate your proof of concept designs and your prototype designs, because at the end of the day, you're trying to design a profitable product. Yep. And it's so easy to work on the design and find out later that the cost is out of control. The bill of materials, I think, is the most important document throughout the entire life cycle of product development, from the very, very beginning till to the sunset of a design. So that's the one document I insist from the beginning.
Good, we agree. Do you want to, so for me, we'll go to the next question. So for me, everything you've said, it sounds like it takes a long time, right? It sounds hard, which is why it's called hardware from what I heard, right? So how long does this take? Like, is this something that I start, stop, and I leave it? Is it something I'm going to keep revisiting, or what does that look like? So give it a go, Ray, first.
You're talking about the entire
process.
Entire process. Well, I'll give the great engineering answer, and start it with it depends, right, on a lot of factors. First of all, I'll use Bob on the bill of materials, so I'll get that out of the way. How long does it take? It depends on the product type, the industry type, what your certification regulatory requirements are. A lot of, depending on the due diligence of product validation has to go through. So I don't know. I mean, to ballpark it, it can take 1 year to 3 years, all told.
And that's through the entire process of really developing the product.
Yeah.
Right.
Yeah.
So up front, how long does preparation take to prepare for that first piece? Is there something that you would say people should plan to spend 3 months preparing for some of this? Is it?
Yeah, I mean, I would. How long is a piece of string? I think.
Classic engineering answer. Good on you.
I think what you can say definitively is that it takes less time to do it than to not do it. Because if you don't do it, the consequence downstream will mean you'll have to start again or iterate in the market with your customer where you've shipped it halfway across the world. Or so I think it really depends on the project. Like, it could take a day or it could take a year, depending on the scale of what you're trying to do. But yeah, definitely doing it versus not doing it takes less time. I also agree with the bill of materials comment. The nice thing about the sort of PRD, TRD bill of materials approach is you can actually do that in a very agile way, because you haven't actually committed yourself to anything yet. Like you're just learning, and then at some point you have to decide, okay, that's the design, and then commit. But yeah, sorry. People ask me in my business, how big is a typical customer? I always ask them, how big is a typical city?
So I learned a dirty little secret in product development. I used to try to benchmark my teams against other companies' teams, and they always seem to have shorter development times than ours. At least that's what the marketing people told me. Why do they get those products out sooner than you do, Bob? It turns out it all depends on when you start counting. What is time zero for the development? And I think every product, before you crystallize and converge on what the product will be, you need to go through the iterative exploratory phase of proof of concept, taking the ideas out to customers, iterating. Then you converge, and then that's time zero. And that can take however long the string is. The beauty is, this is the best time ever in manufacturing. When you can send a file out and get a circuit board back, you send the file out on Monday and get your circuit board back from China on Friday. When you can rapid prototype a physical part, I used to call it the dry cleaning model, in by 9, out by 5. Things that used to take weeks. So these are the greatest times ever. And this is why we need to use this iterative capability to converge on good designs fast. And then when you crystallize on what the customer really needs and what you expect to deliver at a good profit, then you move into the detailed, really deep attention to detail that's all about designing for a manufacturable and sustainable product over its life cycle.
Anything else to add? You're good. So there's lots of people involved. We've talked about the CM a bunch of times. A lot of the questions that come up is, there's also a lot of companies like Sigma Point and what have you, Inertia obviously offering services. So what can I expect from the various partners I'm going to engage with in my product development? So from an engineering development firm to the contract manufacturer to, if I talk to, Aero Electronics, like those types of folks. So why don't we talk, Ray, about engineering development firms? You may know a little bit about this. So what can they expect from you as a partner in DFM in the whole process?
What you should expect from a product development firm is someone's got like a broad perspective of the entire process, and also, I guess, a collaborative and open communication mindset. So, as a startup founder, you know your product better than we ever will. You're spending most of your time learning about what they want and don't want. So we're there to kind of build strategy of giving the perspective, okay, what does it look like to get from where you are now to a product on the shelf? And depending on where you start, at what point you engage with that company, but to give you some, at least high-level understanding of, here are the steps, here's the approximate timeline, here are the approximate costs, and that goes right into manufacturing. Again, putting a number for everything is important, just like the bill of materials. There's a lot of uncertainty. And certainly we can only see as far as we can see. Right. And we're open about that, and we say, okay, well, this is what we know and this is what we think it'll be. And as that process unfolds through the sort of the early iterative stage, all those plans get adjusted accordingly, the bill of materials, the product development plans, the cost estimate, the timing estimates. But when it comes to design for manufacture, I think, or all elements of product design, it's important to have a multidisciplinary team looking at that product simultaneously, to go down one road of like, oh, we've got a great industrial design, now we're going to start to do the design for manufacture. It's like, okay, well, that design is great, but it's going to cost you $500,000 to tool that thing. That's not really feasible. So those kinds of conversations need to be had somewhat simultaneously throughout the process. So.
Yeah, I've seen plenty of designs that more industrial design firm focused folks will do with their zero thickness, infinite stiffness materials that cost nothing, right? And so it's about getting some of that other perspective in and getting some of the experts involved, like a design firm who's done this a few times. So building that team, when should a design firm be involved in the process? When's ideal for somebody like you to be involved?
I guess it depends on how you want to scale your business and how you want to run it. There are clients who we get involved from the idea stage, where like we want a product that fills this niche, and go to it and we figure out the requirements and take it from there. There's I'd say more often the startups I come across from like the likes of the Accelerator Center and Communitech and whatnot, it's, once they get through that sort of conceptual, like, product market fit,
Right.
where they can do a lot of that themselves. Like we can do it too, but it costs a lot of money. So they can do that themselves, and once they kind of hone in on what the product really needs to be, and we just put the pedal down and do the design development and prototyping and manufacturing, that's usually an ideal time.
Mm-hmm. So, Kurtis, you mentioned about bringing in the contract manufacturer and having them involved in the process. So what's good about involving them early in the process? When is the right time so you're not kind of causing more noise than anything? What was your experience with that?
I mean, for us, we bring them in like right at the idea stage.
Okay.
To help us build. So like our approach with the PRD, TRD, and ultimately bill of materials, the CM can often talk to you, whether it's CM or engineering design partner who has a lot of experience with DFX. They can ensure that in your base, like non-technical kind of market-facing requirements, you're thinking about, can you even manufacture the thing? Like little things like, it's way easier to screw something together if all the screws are on one side, right? It'll cut your manufacturing tack time down by whatever, half if you do it right. So little things like that you would never uncover those requirements by thinking about your buyer or your user. You only uncover the requirements when you think about the people who actually have to build it and the people who actually have to build it. Just like a customer knows best what they want, people who actually have to build your product know best what they need.
Mm-hmm. Yeah, it's like having a bunch of different size screws when you're trying to put something together.
Exactly.
It's like,
I think there's a real benefit for long-term relationships with your CMs or your design partners as well, because if you choose well, and sometimes it takes a couple of tries to find a good fit, over time you learn the design rules of the CM, you learn the design partner learns your capability, and if they're a good design partner, you can learn from them, and you can learn from your CM to design better the next time. So I think the best relationships are ones that are capable of being long-term, ongoing relationships for the next product and the one after that.
Mm-hmm. Yeah, I totally agree with that. I think the point is we're not just trying to build one product. We want to build a family of products down the line, et cetera, and having good partners is going to be an important part of that. What about trust? Trust with your contract manufacturer. There's a lot of contract manufacturers, they'll give you the, yeah, they can do it. Of course they can do it. And then you get down the path and they can't necessarily do it. So what have you kind of learned? Is there maybe a horror story about trusting too much, or what do you think, Ray?
It comes down to, I think, a lot of due diligence, and you expect what you inspect. Really, getting to know the people that you're working with, and also aligning yourself with companies that are, let's say, more in line with where your business is at. So it's a part trust, part right fit, because you can find, I've been examples where we have clients who some of them go out and find their own CMs, and they appear to be the most capable because they do a lot of work with big brands, should be able to do the work, right?
Yep.
But you're making 1,000 pieces, you're going to be the last person that gets attention in that company. But when it comes to trust, making sure you're dealing with the owner or the high level management team of that CM. If you're going offshore, there's another level of due diligence that has to be done there to make sure you know who you're dealing with.
So I don't find CMs on Alibaba.
Yeah.
Good.
Because there won't be a CM; it'll be a middle
agent
person.
of a
Yeah, an
yeah.
agent. So it's easy to do that, and anyone can do that.
Right.
If you want to protect yourself and make sure you know what you're getting into, you have to do the homework, and that goes for a lot of what happens in hardware design.
Good, Bob.
I have a horror story. What CMs will often do, even if they promise not to, is substitute components, substitute suppliers. And of course, your design may be really dependent on a piece of metal being bent on somebody's process from this supplier that some other supplier could make the similar part that can't quite meet those same performance. One horror story we had was at Christie Digital. These are really high-quality projectors. And the manufacturer of our zoom lenses, we designed it and they manufactured it, decided to change the supplier of the glass they use for the lenses from this company to that company, and it was equivalent, and they forgot to tell us, and we ended up having, I don't know, a couple $100,000 of field retrofits because of it, because it really wasn't equivalent. So it's your job to make sure your contract manufacturer is committed to not making substitutes without telling you, and it's also your job to make sure they actually do what they say they're going to do.
So not to terrify you even more, but I also have a horror story. So similar idea. So we always say trust but verify. So we have one of our products uses little memory cards, like SD memory cards, right? And when we first started out, we were buying just consumer grade SD memory cards, but our customers put these things out at minus 30 degrees and plus 50 degrees, depending on where they are in the world. So we started finding that, we're recording video, and every once in a while we'd have an SD card that would just fail, right? And this is causing all sorts of support cases. So at some point we decided we need to move to an industrial grade SD card. So go through a whole process of validating that this industrial grade card will work, all sorts of temperature cycling and thermal testing and everything. And so the CM didn't change the supplier. SanDisk changed the supplier, and the controller, which is I don't even know, it's like a grain of sand that goes inside of an SD card. The controller chip that controlled the memory that wasn't the thing we had validated, and then we started seeing all sorts of field failures, and after pouring through all sorts of possible things it could be, found out that it was the controller inside the memory card that someone had just changed, not told us. So it's tough to trace it all the way through, but yeah, you have to be that neurotic about it.
Part of it's having a good process in place, and sometimes CM will do something without you doing it, and that's difficult control. I think it comes back to the communication and letting them know that if things are changed, what the repercussions might be, and we've spent a lot of time educating on products of these are the reasons why these components have been selected, and if what happens if something goes wrong or is changed, and you can have a engineering change order, whatever that has to go through all the revalidation, recertification, and whatnot, and try to at least bring that kind of level of due diligence to the conversation, so people understand that if we make a change, we should probably have a conversation about this. At least having that conversation with CM leads them, gets them, understanding that maybe we better check, but sometimes things still happen without you knowing, and just I think the more they understand about the product, or the more that you can help them understand about your product, maybe the more forthcoming they might be.
Now, I have yet to meet a startup with an ECO process, an engineering change order process. I rarely see one with a bill of material. That is formalized classification of components and what have you. So what are some of the things that can, what's a good, Bob, this is for you, what's a good bill of material look like?
The bill of material, of course, evolves through the product life cycle. At the beginning, it's simply a spreadsheet. Well, I mean, at Christie, we used Oracle, and or SAP or whatever, but for a startup, a good bill of material is simply a list of parts categorized by major function with an identification of the quantity, the price, the anticipated price at different volume breakpoints you have to remind yourself of minimum order quantities. And that's the tool that you're going to use for analyzing cost at different stages. And of course, that tool at different phases has uncertainty to it. At the beginning, when you do your first bill of materials, when the light bulb goes off in your head, I always added 30 to 40% contingency, simply because you don't know. All the way through going into first pilot production, I would still leave 10% in there because stuff happens. So the bill of materials forces through that conservatism, forces you to scrub that much harder to reduce your parts count, to choose your suppliers more sensibly, and plan for the overall life cycle. The bill of materials should also support you in your inventory planning process, because once you're in production, suddenly you have to deal with inventory, production runs, you have to deal with material planning to decide when you're going to order new material, and that's when you need to consider evolving to a more formal. You don't need to consider. You really ought to move to a more formal ERP or at least MRP system. There are some open source ones like Odoo. There's lots of commercial ones, but you need to plan it. So much of manufacturing is actually boils down to nothing more than attention to very mundane, boring detail, doing it every single day, because that's where the success of your business and the avoiding of huge inventory write-offs occurs.
I'm curious from a Miovision perspective, when did you kind of graduate to a more formal process? Like, I'm assuming you would have started with bar napkins and then eventually graduated to something. So what did that look like for you?
Next week.
Yeah, okay, I'm turning your mic on.
I think it's an evolution. There's always a trade-off between rigid process and velocity, right? Like, I would say in many respects we are still in the spreadsheet, so to speak, in lots of things, because it's just the best tool for the job. We were 14 people when we implemented NetSuite, which was early, but we sort of decided to lay down the IT infrastructure to scale up. So we've had a ERP system to manage supply chain, like the link all the way from sort of order to supply chain, really since the beginning. But in our design and even in like handoff into manufacturing, a lot of that's still done through Jira and Google Docs.
Better than a bar napkin.
Yeah, we've moved on from the bar napkin.
Rev control?
For some things. Most of our innovation still happens over
fair enough.
beer. But.
So we talked about CMs and engineering firms. What about guys like Aero, Abnett, TI, CSR? Like, what's their type of involvement in DFM assembly cost? You want to give it a go?
One thing they do is they have tools that'll help you predict parts obsolescence. Mm-hmm. This is hugely important. You think when you've got your design into production, everything's cool, you can move on to the next thing. The second law of thermodynamics, which says the world's always getting more chaotic, kicks in, because some supplier of some little tiny 20 ohm resistor that you've chosen for whatever reason has decided to obsolete that part, or some more complicated one has to get. Connectors are the worst. Some connectors no longer available, and you can't get one with the same form factor. Companies like Aero have tools that'll help you predict when parts are going to get obsolete, so you can at least know ahead of time when you need to prepare for it and manage it, as opposed to simply react. So I think this is a hugely important tool you ought to use.
The other thing that, the other service that's available, like I know, for example, Abnett has a really good sales engineer. Can't remember the guy's name off the top of my head, but
Adil.
Yep, Adil. Yeah. So if you can find a really good SE to involve in your design at the design phase of your project, they have in Adil's memory banks, I'm pretty sure he has the entire catalog of Abnett, and knows exactly how to apply it in your specific voltage need. But they can save you a ton of time in terms of having to pour through manuals trying to find the right components, because they've used all these components hundreds of times with hundreds of customers on hundreds of designs. So that's another one I'd say they're free, so you use them.
Mm-hmm. Right.
Similarly, we use them a lot for design input. So, this is the general idea of what we're trying to do, what we suggest for LED selection, right? And they'll go through the catalog and they'll be able to hone in on the right component for your product much quicker than our engineers would. With Aero, I know we've had a few clients go through them for some kind of like from some early supply. They do, I guess, give very generous terms on like first run production, which a company like us wouldn't be able to do that because they'll, I don't know, like 4 or 6 months payment terms or something like that. It's a pretty good deal for a startup.
It's interesting. So shift over to kind of maintaining the manufacturability, assembly, and test, and cost from a long-term perspective. You talked, Bob, about when a part change is not just a part change, and so what are some of the long-term implications, and what are some of the due diligence that people should be considering when they have a part change on the table?
When you're in manufacturing, when you're in production, you've got your product being built, it's in the field, change is the worst thing that can happen. CMs hate you, or if you're manufacturing in-house, your manufacturing people hate you, because any change will probably cause either rework on the factory floor, rework of spare parts that you've got. It'll affect how you, it may cause some boards or some components to have to be thrown out. So basically the price of freedom is eternal vigilance, and one just needs to constantly watch for change and plan for it. When you plan, one of the things that surprises a lot of startups, surprised me when I was a young engineer, is when you finish your design and it's in production, you think, okay, all those resources can go over to the next design and go working on that. Well, it's not so. You have to deal with this kind of stuff that happens that's outside of your control and be prepared to deal with it. Even though it's outside of your control, you can anticipate changes, be prepared for them, deal with them quickly, and minimize your inventory costs, your write-off costs, your obsolescence costs, all of these things that actually don't show up on your bill of material, but are real costs nonetheless that'll affect the health of your company.
Mm-hmm. Yeah, it's interesting because when I was a younger lad and starting off in engineering, Adil used to work for me, which is kind of funny. That's why I know him. And he, brilliant guy, but he always came with different part swaps and changes and what have you. Even back then, we had Aero and Abnett trolling the company, going, "Hey, give me your bill of material, and I'll see if I can get some cost out for you, etc." So, what are some of the pros and cons of the activity of when you just kind of give your bill of material over to one of these guys? What happens, and is it something I should be doing, or should I defend my bill of material from wide use? What are the thoughts on that? Any risks?
I mean, assuming you've protected your IP, I don't see any issue with giving them the bill of materials. The only thing you got to think about is just like you're gonna have to, if you've been diligent about qualifying every part, then if just because you can get it for cheaper, you should go through and requalify every part. I never used to do that, but you learn the hard way that you need to. Yeah, so I would say, by all means, if you can save money, try to save money, but just be prepared to go through. If you had 75 tests that you said at design time you needed to pass in order to call your product done, and you go out and change a bunch of components, you should be prepared to do every single one of those 75 tests again to make sure that you actually still pass, because you probably won't.
Just to build on that, maybe not just specifically for handing bill of materials over to those companies, but the knock-on effects of the changes again. So we've had a couple companies come to us say we want to reduce the cost of this product we need to by so much, and then when you add up the engineering time, the recertification costs, all those things add up, and you say, okay, really, it doesn't make sense actually, and the risk is quite large for you to do that. So,
just to give you an idea of like how many of these types of things can go wrong. So we we switched out some resistors at some point because it was cheaper. You'd save 5 cents a resistor or whatever, so you change them out. The new resistors had, so, you know, nothing in hardware is the same every time, right? So resistors have a tolerance, right? So we switched them out. The ones we picked had a wider range of tolerance. In the code for the ARM processor we're using, we were trying to maximize performance, so I don't profess to understand all this stuff, but there's some threshold we set on a voltage level that was like right at the margin to maximize the performance of this chip. So we start seeing all these intermittent failures in the field, because if the resistor value that we put in there had a variance that was over some range, it would throw the voltage out of whack and it would cause issues with the chip. And so something as simple as like a 10-cent resistor can cause massive recall if you don't go through the motions of retesting everything.
I have a resistor story too on one of our video boards. You know, it's a 10-cent part can, in this case, cost us $500,000. We had a product in the field. We had multiple thousands in the field. And at some point early in the production, we changed from a potentiometer, a 10-cent part made by Bourne, to one by Dale. And it turned out that we forgot to check that the new part wasn't quite compatible with the flux cleaning process that our board manufacturer used. Moisture was creeping into this part, and it would have been okay if it had failed right away, that we would have found it and dealt with it. What was happening is these parts would fail over 3 to 6 months. So, you know, we were 6-9 months in the field before we realized we had an endemic problem and we were able to isolate it. So attention to detail is really crucial.
So I have been asked to ask if there are any questions from the field. Are there any questions? Please go ahead.
So this is like, I recently graduated from engineering, and I kind of like, you know, gathered knowledge from myself, and I know that probably wouldn't anyone ask this question, but it's kind of like the dark side of engineering. So I know some things are definitely designed to fail, and the design to fail, so you buy them again. I mean, for example, is an iPhone. iPhones last longer. I think of an iPhone 4 with a button. It was like designed to fail. Literally after 2,000 pushes. So like when you got 2 years into it breaks. You need a new iPhone. But hearing a lot about, you know, back and forth between if parts get changed further down the manufacturing line. I guess what I'm asking is there deliberate engineering from your perspective, like a business case, to introduce failures that are acceptable to your clients for the purpose of making them auditing answers?
So, yeah, I don't know that we've ever gone as far as to design it to fail, but there is the concept of mean time to failure.
Yes.
And there's definitely trade-offs in MTBF where you design it, where you can design a 5-year mean time to failure or a 10-year mean time to failure. You know, extreme case, if you wanted a 100-year mean time to failure, that's a very different design than a 2-year mean time to failure, right? So we generally would come at it from that perspective. I don't know that we've ever come at it from the, I guess,
Evil.
yeah, 95th percentile time to failure, I guess.
I know they're going to come back and buy more.
Well, it turns into a pumpkin.
It's hard enough to design reliable products.
They're not that smart. There's another question in the back. Yeah, go ahead.
I'll just add to
sorry.
you know, especially with consumer products, you can never fully appreciate what people do to them out in the jungle there.
Yeah.
And you know, you design tests to try to simulate, you know, they get a little machine punching that button, and it lasted 4,000 times, and everybody was happy with that. But no one expected it for someone to be sitting there doing, you know, this with it 10 times either. So. Really things happen that you would not expect with products, and as a product designer you have to expect those things to happen and try to think of those things that can happen, because a lot of times people will naively say, well, no one would ever do that. Yeah, they would do that.
No, absolutely. Go ahead.
So if you use the design services like from Abnett, for example, to help you design your product, is it, I guess we should advise going around to different electronic suppliers to get quotes, like go to Air afterwards, or is it kind of like etiquette to stick with the person helping you?
I mean, I mean, it never hurts to price shop, but I mean, they offer those services. They're hoping that you're going to buy from them at the end. But keeping them honest isn't necessarily, you can still go back to them and buy from them, just nothing against the price.
There's nothing, there's nothing stopping you from negotiating, certainly. Just, if they went through all the work with you, continue to work with them just from an ethical perspective is something I've always recommended. Because they can help you a lot, and usually they can be very competitive, but keep them honest.
One thing to keep in mind too is if there's proprietary components that are in that design, then you can't really pick it up and take it somewhere else either. But,
right.
But yeah, I mean, you want to try to start with the best of intentions and figure out if that's the right company to work with before getting too far down the road within the relationship.
Any other questions? Go ahead.
If the cost of manufacture keeps coming down, would you guys want to bring that kind of stuff in-house? Would you want to take over the work of a CM internally?
Personally, we wouldn't. Building a business, there's a lot of things you need to focus on, and in my experience, the fewer things that you need to be the best in the world at, the better. We're not the best in the world at CM, and probably never will be. So, personally, I wouldn't bring it in.
Right. Any more questions?
At Christie, we did both. We used a range of CMs, Jabil, for example, for a couple of our major product lines. On the other hand, Christie's got a very sophisticated manufacturing process on Wellington Street here in Kitchener because there's certain very skilled activities that need to be done to optically align the precisely projectors. So it's a decision, and it depends on the product, and sometimes you can't outsource a particular thing.
Yeah, it depends on your business and what you want to focus on and what kind of product you're involved in. So similarly, we have a client, we supply most of the components, but they do the final assembly because it's an electro-optical device and they need to do final assembly and adjustments and alignments with a lot of liquid shims and whatnot. Just want to figure out what you want to be good at, because manufacturing is a whole business into itself.
Yeah. Any other questions from the field? Okay. So one of the things that's interesting that they touched on is the need for sustaining engineering, and which is that team who has to deal with all the crap that got left behind and field issues and what have you. So when we're looking at life cycle costs, how do I consider that as part of my overall business plan, like from inventory, from team staffing, just in general from running the business? I don't know. Do you want to give it a go to start?
Yeah, I mean, it generally won't be zero, so start there.
Like how many people do you have on some of your products as a sustaining engineering?
I mean, you can generally get away with like 1 or 2 people if they're jack of all trades. It never really works out where it's like one person,
right.
but it might be one equivalent person spread out across a bunch of different skill sets. The other thing you do, we do this, is you will, no matter how diligent you are with all the things we've talked about, you will run into a field warranty issue where you have to do recall, like it's inevitable. So the other thing we do is we put a charge on our P&L for every unit we ship. We put a charge, like a warranty charge. So we sort of, even though the cash flow is, you're kind of accruing this buffer essentially for a while, and then all of a sudden all hell breaks loose and you have to deal with it. At least in your financial statements, it doesn't look like that wobbly, because it's all kind of on your balance sheet.
It's the concept of a piggy bank.
Yeah. Right. So that's the other. There's like the people aspect of how do you sustain, and then there's the financial engineering side of it.
Bob, when you had obviously a fairly large team of engineers, what have you, what did it look like?
So we would maybe 15% of the development organization would be sustaining. But what we did is dealt with not just the life cycle management. The sustaining team did some minor incremental improvements to the product as well. Okay. So adding small features and so on, so you could get value add from them as well as surviving from them. So that's how we did it. We also reserved for warranty costs as well for the very same reason. That was good advice.
Very cool. Do you have any other thoughts, Rick?
Not much. I mean, we do a little bit of sustaining engineering for some
Okay.
clients.
Yeah.
So I would say, yeah, the 10-15% is probably
Yeah.
probably a reasonable estimate to what compared to the normal new product development team. Yeah.
So I'm curious, just from an expertise perspective, you know, there seems to be experts in everything, and so have you seen experts in DFM who walk you through the process or kind of lead that, and even like the way a Scrum Master would through project management stuff? Have you guys seen that?
I've come across so I came from the automotive industry, and they've done a spectacular job of benchmarking every single vehicle out there and what it costs and the time it takes to assemble each and every component. There's benchmarking facilities in the Detroit area that are just massive warehouses full of disassembled vehicles with little Gantt chart timelines of every single sub-assembly, and they know exactly how long it takes to put, you know, their competitor's car together and what makes that car competitive. So, I mean, they're doing the same product over and over, and it's a fairly well developed industry. So there was, I'm trying to remember the name of the gentleman. I can send it out after, but there's one gentleman or a company that's set up as a expert in that field that's come out of automotive, and I know they do a lot of design for manufacturer training here in the Detroit area as well as overseas.
Have you seen any?
Yeah, not like specific companies. For the size of company that we are and that most companies here are, I've always found the best, and it's usually free, but the best people to provide the advice are the people who are actually going to make it for you at the end, like the CMs have often, but there may be more dedicated groups.
No, it's a very reasonable answer, is that, you know, trying to get as much free resources as we can, and partnering with them is not a bad idea, right? Whether it's in-house or a contract manufacturer.
A good thing, if you can do it, is to get your hands on your competitor's product and tear it down and steal their ideas, because they're doing that with your product. So
it's called leveraging best practices.
Yeah, exactly right. So,
That's R&D, rip off and duplicate. Yeah, that's a great point, and thanks for bringing it up, Bob. That's one of the things we've done often on some products is buy, you know, a dozen of the competitors and strip them down and understand, you know, best practices, manufacturing methods, and you know, there's things that you want to innovate on, and there's things that are just sort of the baseline, you know, get it done. You want to have your value proposition and your differentiator, but the rest of the stuff you should be learning from, you know, you might as well learn from other people rather than going through that learning process yourself. And
it's interesting, it doesn't even need to be an exact, you know, direct competitor. It can be form factor specific, it can be, you know, adjacent space, you know, a multi-port switch. How did they put it together if you've got this chassis type product? So, because a lot of people are doing things that are completely new, of course, but you can find some interesting options that are just out there. You know, take the credit card to Future Shop, or Best Buy now, I guess, sorry, and, you know, tear some shit apart and kind of see how they're doing it. Look for the mistakes they're making and learn from their best practices.
I think also just trying to find people that have been through those events many times is a great place to start. So you can have, you know, your design engineers, manufacturing engineers, and things like that.
Right.
And coming out of school is difficult to have that perspective and experience. But, you know, someone like Bob who's been through it many times, is you can leverage people like that. It's going to be the most value that you could find, I think.
So without crashing any stock prices, what are, you know, some examples? You told me about the 10-cent resistor that cost you $500,000 or whatever. Any other examples that you have that just kind of make people, as we're getting ready to leave, go, shit, I should pay attention?
I would say, I'm not going to, I won't say any disasters, and I have to be careful about who I'm talking about, but,
don't tell any names.
I think, you know, it can be a challenging position as a service company because you want to do the best for your clients. Your clients have a vision and a way they want to do things sometimes, and I can say you can recommend once or twice, and after that you're arguing, and you don't want to do that. So we've bring it back to that point about determining what features to put in a product. We've gone a certain way down the line of design and development, kind of having those discussions about cost and feature content, and with the customer's focus of like, oh, it's got to have all this stuff in it, right? And knowing you're like adding things up, you're like, it's going to be expensive. Like, well, let's wait to see the end. And of course, when you get to the end, it's okay. Well, what are you going to do? You're going to get better sourcing. We can maybe take a few % out of that by finding a better manufacturer. While you can cut materials, or then you have to start cutting functions because there's a certain amount you can do. So, so we've recently been through 2 of those situations where we try to advocate and say, okay, like these are concerns we have about the product cost. We don't think we're going to be able to make it based on these factors, to get to the point where we have to like back up and spend 2 months to redesign, and that's that could be $100,000 in 2 months. A cost. If that's sometimes people are happy to do that or willing to do that. It's not always it's painful.
Well, risk reward sometimes too. But.
Yeah, exactly. So.
Okay. We had one. This is really early days, and we had a prototype product that we brought to a trade show, and we were using 2 large, like not quite car batteries, I think like maybe motorcycle batteries inside this unit to power the thing, and we had the leads that were just plugged in, and I tipped the unit over to show the customer how easy it was to attach the cable to the bottom of the unit, and I guess the positive things from the different batteries touched each other, which apparently isn't good in electrical engineering, and they burst into flames, and the unit was designed to be waterproof. So when I closed the lid, it stopped the thick brown smoke from like coming out of the unit, which was nice. And then I just turned to the software and said, and over here, you upload the video. And it smelled like toxic smoke for the next hour, and people were walking by like, what is that? Yeah, I don't know. It's like the air conditioning. So.
It's well known in electrical engineering that it all runs on smoke. And, when the smoke gets out, you're screwed. So that's awesome. So I've been told that we are now over time. David is getting upset with me. He's a big guy. He's kind of scary. So we're gonna shut her down. If there are any other questions, please feel free to ask them, talk to us. Certainly, David is a good contact if you have any ideas or questions further about DFX. And we're going to be doing these over the next few weeks still. So, David, do you want to tell us about the rest of the program?
2 things. One, Don was sending me much meaner messages than I was sending to him. So, there's that. And 2, Don last week was really, really pushing for a fire story, and Kurtis, that exceeded all expectations for what we were hoping for. So
fire story.
And also just want to give a huge round of applause to our panel and Don for moderating it. That was some really, really great discussions, and I personally learned a lot. So just another quick round of applause for them because they were amazing. And yes, we are over time, so I'll leave you all to enjoy the rest of your afternoon. We are going to be doing this again next week here, and then the week after we're going to be doing one more session in City Hall, but it's going to be downstairs. Really would love if you guys showed up. I think the next 2, which are going to be on user experience, usability, as well as reliability and durability, are going to be really, really good. So I encourage you all to show up, and if you need to talk about anything regarding the sessions and you can't get a hold of one of these, feel free to grab me. I'll be around for the next little while, okay? All right, thanks, guys.